Okay. So nano diamonds are basically diamonds of nanometer sizes. Okay. So you can have, diamonds ranging from 10 nanometers to 100 nanometers, 1 micrometer, those ranges. And they can be made in labs. Okay. And you can make them through different methods. Is there a bug? Yeah.
Yes,
Sorry.
there was a please tell.
So you can make them through different methods. Okay. The most common method is something known as a high pressure, high temperature method. So basically it's like a big giant pressure cooker and you heat it up to very high temperatures and you have some explosive device inside or explosive material inside and the
Mm-hmm.
material explodes.
Mm-hmm.
And because it is carbon-based explosives, you get diamonds. And that's exactly how diamonds are found naturally as well, like under high pressure, high temperature. So we just do that in the lab. Once you get the diamonds, they're all carbon-based materials, and it's very easy to think about biomedical applications because every single thing is carbon-based. So it is biocompatible, it is very stable, it does not harm the body, doesn't harm the environment. So the applications can be quite a bit.
Like,
So what we're doing now is we're using diamonds okay, so diamonds, because of their crystallinity and their hardness, you cannot really do any chemical treatment to them. It doesn't
mm,
work, okay,
mm,
because they're too stable to go through any sort of chemical treatment. So what we are doing is we use high energy ions to bombard these diamonds to make them optically active, okay.
mm, okay.
So basically being optically active means they give you a, uh, okay, like your glow in the dark materials, like
Mm,
your when you're traveling by road and then your road signs, when your headlight hits the road signs, it kind of glows, right? It reflects. That's how
mm,
you see it very clearly. That sort of a thing. So those are like fluorescent materials. So
mm,
we are trying to make our diamonds fluorescent.
mm,
And we try to make them fluorescent in a specific wavelength region because your if you're doing biomedical imaging, the fluorescence needs to come out of your skin. There's no
obviously.
point in the diamonds being inside it fluorescing and you cannot capture any light coming out from the diamond. Basically, we want the diamonds to shine light. Okay. If you take a torch and you
Mm,
cover your hand over the torch and the torch is on, you can see your blood and, a little bit of stuff like that, right? That's because your torch bulb is usually a halogen lamp. A halogen lamp has wavelengths from I think 400 nanometers all the way to about 1000 or 1100 nanometers. The region between 700 nanometers and 1100 nanometers is transparent to the skin. So it goes through the skin and that's how you can see, the blood and everything inside, which is exactly what we're doing in diamonds. So we're trying to, make it fluorescent in this wavelength region that the light comes out of your skin.
mm,
So we do some sort of doping using high energy ion beams
mm,
and then we take some cells in a petri dish, we mix the
mm.
diamonds with them, and then we take the images of those. That's basically what it is in a nutshell.
And then where are you planning to use them? Where are you planning to use this application? Like
So
this
we are
thing.
trying to come up with a, okay. You want me to go into technical details now? Okay. So basically what we're trying to do is try to identify cancer at its earliest stages. Okay.
Okay.
And the cancer which we are focusing on is the colorectal cancer, the stomach cancer. Okay.
Mm-hmm. Mm-hmm.
So, the stomach has a lot of bacteria in it, right? So this bacteria sometimes, under certain circumstances, it stops functioning the way it is meant to function. And you have and then the stomach gets, you have stomach ulcers, right? You've heard about stomach ulcers. So
Mm-hmm.
these stomach ulcers are caused by the bacteria in the stomach. It is a disease known as inflammatory bowel disease.
Mm-hmm.
Okay. Usually, in a lot of cases, in most of the cases, it goes as it is.
Mm-hmm.
You take medicines, antibiotics, and it goes. But under certain conditions, this is the early onset for colorectal cancer.
Mm-hmm.
And there is a direct correlation between the bacteria and colon cancer, we want to know the exact time that happens.
Okay.
The exact time inflammatory bowel disease becomes colorectal cancer through biomedical imaging.
Okay.
And that's where we use our fluorescent diamonds.
So how will they be able to tell? Like I'm just curious. Now I'm
Mhm.
getting curious about these things.
There are certain signals. So basically, once again, it's all about understanding the data that you get, processing your data, analyzing your data.
Mhm.
That's where data analysis comes in. So there is always a difference between, say, a healthy gut, a healthy
Mhm.
stomach,
Mhm.
an inflamed stomach with just bacteria, and the early onset of colorectal cancer. There's
Mhm.
always a difference in the signals that you get. There's always a difference in the data. So we
Mhm.
try to optimize, or trim that data to the, earliest possible moment where you can say that, okay, this is the threshold point. Beyond this, you have colorectal cancer. Before this, you have inflammatory bowel disease.
So
You just
that
process the data that you get
so that
so that you know
diamonds.
that, okay, mhm.
Mhm. Please, please.
Yeah, no, so that we can, or the clinicians can give the patient a clear picture that this
Mhm.
is what is happening. These are the steps you need to take.
So you will be sending those diamonds in the stomach first, and
Hmm.
then take its imaging to tell whether it will be like this thing or that thing. Is it going to
Obviously,
happen
that
like
is the
this?
idea. Obviously, that is the idea, but these would be the clinical trials portion, which is way beyond our scope.
Mm.
So right now, as I said, since nobody has really done this before, we cannot directly go on test on humans. So we need to first do it in the lab. We do the Petri dish thing. We do it on cells. We see if it is working. You can get cancer tissues to work on in the lab. So we can do it over there in the lab. The next step would be to do it on mice. So we test it on mice. Then it would be like higher primates and stuff, but then that is beyond the scope
That
of this
is like
project.
a long process. That is going
Yeah,
to take
yeah,
a lot and lot of time.
exactly,
So anybody from the audience who just wants to work in this field, call him. Just send an
exactly.
email to him
That's
as
it.
a part of this podcast also.